Welcome and thank you for always joining us. We are still on variations. We are at question number 4, and the question we have reads, given that x varies directly as the square of y, and x is 2 when y is 1, find x when y is equals to 4. Before we come to find, the first information given is to get us the value of the constant of variation before we substitute the final values to get or to answer the question. We can proceed as follows. X, we have been told that it varies directly as the square of y. Once we have done that, we come down and say x is equal to ky squared. For us to be able to find the value of the constant, we divide both sides by y squared such that k becomes x over y squared. From here now, we have been told that x is 2 and y is 1, and therefore k is going to be equal to x, which is 2 you divide by y squared. Remember, y is 1. If you square 1, you still get 1. This one will give us 2 over 1, which is exactly 2. Once we have gotten the value of the constant, we write an equation connecting the variables. The equation is also known as the law, and the law is going to be x being equal to ky squared, but remember we have the value of k, which is 2. Then we are going to have y squared. From here now we can be able to answer the question, find x when y is 4. So we can say when y is equals to 4, the value of x is going to be equal to 2 times y. Y is 4, but 4 is squared. This is 2 times 16, giving us the value of x as 32. Remember to subscribe and also help us to share the link. We are now moving to another question, which is a question number 5. This question was examined in KCSE 1993, paper 2, question number 5. The question reads, the mass of a certain metal rod varies jointly as its length and the square of its radius. A rod of 40 centimeters long and radius 5 centimeters has a mass of 6 kg. Before we go to the main question, we must use the first information to get the value of the constant. From here, we know that the mass of a certain metal rod varies jointly, so it varies jointly as the length and as the square of its radius. So we multiply by the square of r. Because this is joint variation, the variables are connected by a multiplication sign. So from here we can move down and say m is equals to k l r squared. Having done that, we can now move down and get the value of the constant. Remember, our L is 40. We also have the radius as 5. We also have the mass as 6 kgs. We know for us to get K, we are going to divide by L r squared on both sides, such that K will be m over L r squared. From here now we can substitute. We have m, which is 6. We divide by L is 40. We multiply by radius. Radius is 5, but it is squared. From here now we can say K is going to be equal to 6 divided by 40 times 25. And this one will give us 6 over 1000. Once we have the value of K, we come and write the equation connecting the variables. The equation is going to be m being equal to k, which is 6 out of 1000. Then we multiply by l r squared. Once we have done that, we can now be able to proceed and answer the question. We have been told that find the mass, so we are supposed to find m when the length is 25 and the radius is 8. So using our equation, we know m will be equivalent to k, which is 6 over 1000. We multiply by the length. We have been told that the length is 25. We multiply by r squared. Our r is 8, so we square 8. We are going to have 6 over 1000 multiplied by 25 multiplied by 64. And if you work out this particular question, you are going to get the answer that is equivalent to 9.6 kilograms. Remember to subscribe and also help us to share the link. Then now we move to the last question, which is question number 6. And the question number 6 reads, the frequency of a vibration of a given string is directly proportional to the square root of the tension T and inversely proportional to the length L and to the diameter D. If T is increased by 50% and L is halved, calculate the percentage change in the frequency. In this case now, we are going to have to formulate this. We have been told that the frequency F varies directly as the square root of the tension T and inversely proportional to the length, that is 1 over length, and also the diameter. From here we can move and say F is equals to K times the square root of T, then you divide by LD. This is our equation, but the equation is not complete until we have the value of K. From here now we can move. Since we are simply getting the percentage change in the frequency, we can say the original frequency will be equivalent to 1. Then we proceed and get the change. We have been told that T increases by 50%. That means it is going to increase to 150. It's going to increase to 150 out of 100. And this one is going to give us 1.5. And we have also been told that L decreases by half. Therefore, we are going to have L decreasing to 0.5. You're going to have L decreasing to 0.5 there. Once we have done that, we can now find the new F. We can now find the new F. The new frequency is going to be equal to, will be equal to K. We multiply by the square root of the new T, which is 1.5. We divide by 0.5. We multiply by D since we have not been given D. From here now we can move and get K being multiplied by the square root of 1.5 will give us 1.225 divided by 0.5 D, and this actually is going to give us 2.45 divided by d. Remember, d and d will cancel at the end of the day. So we are simply going to have k over d being equal to 2.45. From here now, we can be able to find the change. To get the change, we take the new, which is 2.45. We minus original is usually 1, and this one is going to give us 1.45. To get the percentage change, we are going to have the change, which is 1.45 divided by 1, we multiply by 100, and this one gives us exactly 145%, meaning therefore we can say the frequency increased by 145%. The reason why we assume it's an increase is because the value we have obtained is a positive. If it was a negative, we could have said the frequency decreased and vice versa. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two. You click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. And for personalized tuitions and consultations, you can feel free to contact us through the number 07 01686 283, and we shall be glad to assist or to render our assistance.